So the first topic, so inventory models. Do you have any idea what is this? The inventory models is, what is it for, or why is it so important, etc. What is the need of studying or making the inventory models? Or what all information do we get from this inventory model? Or what you meant by the term called as inventories?
Inventory is the storage of goods for a factory. We'll basically discuss about the replenishment of the goods for the distributing to the customers, and maintaining the sufficient stock in the inventory is important for.
Yeah, okay, right. Exactly what you told is right. Okay. So now you were talking about stocking the quantity in the factories. Okay. So if you were studying, you might have studied about the electives called lean management. What is the purpose of that subject, or the objective of that subject called lean management? I hope that it was offered you as an elective in your last semester, or might be on this semester.
This semester, sir.
Yeah, this semester. Okay, that's fine. What is its objective is? What should be lean on industry? What should be lean on industry?
Sir, is it optimum usage of resources and without much wastage, sir?
No, no, no. So in industry, in any industry, the inventory should be minimum. So what is inventory in industry? So if I running a business, anything which does not add any value to my pocket is an inventory. If I am holding excess raw material, that is inventory. If I am holding semi-finished goods in front of every machine or in front of every buffers, if I am keeping, that is inventory. And the final finished product also, which I am not selling and keeping it in my stock, that is also inventory. So basically inventory is nothing but all this together, unnecessarily stocking of raw material, unnecessary stocking of semi-finished goods, unnecessary stocking of finished goods. So these all things are added together to an industry called as inventory. So inventory should be as minimum as possible. And you might have seen some of the tools which can be used for lean manufacturing, etc. in that elective. So here what I am going to talk about is that, as somebody had pointed out the terms, okay, some terminology somebody have told me called order quantity. Okay, so order quantity. So in another way, if I elaborate it little more, that is called as EOQ, economic order quantity. Economic order quantity, it is called EOQ. Okay, so economic order quantity will gives you an idea how much quantity you have to hold, how much quantity you have to hold. So that gives that computation is done with the help of this EOQ calculation. And So this will give you the numbers. Second information, what you can compute from this is that when to place the order. Okay, when to place the order. That is the order interval, etc. Okay, so certain companies will have its own procedures. Okay, for procurements. Okay, certain companies which you are placing the order, they will say that they can only supply the goods. Okay, after a certain period of time when you place the order. It's called lead time. So these are, by looking into all these information, you have to make sure that when to place order and what quantity you have to place the order. So that is what is basically you will be solving or solving mathematically in this chapter called as inventory model. So there are plenty of types of inventory models are available. Depends on the market and depends on your supply demand conditions. Okay, so the base one or the simple EOQ, it will be something like this. Okay, so the you have to access X and Y. Okay, so the X-axis it is time. Unit will be in days normally, and in the y-axis it will be quantity. Okay, it will be quantity. So initially in your stock, okay, initially in your stock you have a maximum stock of your product will be available. Okay, so that is the maximum stock. Okay, and as the time progresses, you can see stock will be emptied. So at some point that will reach to zero. Okay, sometimes you will not allow it to reach to the zero. Okay, there will be always, in the case of any industry, you will keep a term called safety stock. Okay, you will keep a term called safety stock. Okay, so this gap is normally called as the safety stock. That is beyond this, beyond this point, you are not interested to fall your stock down. Okay, so you don't want to lose the customer, so you are not interested to fall your stock beyond certain point. And the top line, what I have shown to you, okay, the maximum one, so that will be the maximum inventory that you will be holding in your plant. Okay, so that will be the maximum inventory that you will be holding in your plant or in your facility. So once this point has reached, your supplier will be supplying the order quantity. Okay, the exact order quantity, you will be back to your stock like this. Okay, then what happens is that again the item got replenished. So again the order come. Okay, again it is going like this. Okay, so this cycle will continue. Okay, so this cycle will continue like this. Okay, the cycle will continue like this. Now here the half of the stock whatever you are holding in your industry, that is called as average inventory. Okay, so this is called as the average inventory or 2 by 2. Okay, that is Q by 2 and this is Q. Okay, so now this is one particular model. I can make plenty of models like this. Okay, I'll show you. So one is I had a maximum stock. It is replenished like this. Okay, then you are not providing the complete terms into my stock. You are also supplying only on smaller order quantities. So instead of going for a steep rise of stock, okay, my rise is also not in the form of a steep. It is in the form of a slow. Okay, again this will continue. Okay, so this will continue. So this will be an another inventory model. Okay, this will be an another inventory model. So a third one I can show you. Certain items will have some demands in certain periods. For example, air conditioner, or if I say fan. Okay, these all things only will have seasonal demands. So when a season comes, then only it demands will rise. So there are season and there are off seasons will be there. So what happens is that in one case the demand goes like this. You got an order, it went up. Okay, the next duration it will be short. Okay, again the order came. Okay, that again it is a different fashion. So likewise then again that will again repeat back into the larger case. So seasonal demand. So here all time frame was uniform between every point. Okay, the time is uniform, whereas here the time is not constant, the time is varying. Since the demand is varying as the seasons are changing, so accordingly your time fraction is also going to change. So these all are kind of different EOQ models, some of the EOQ models. And sometimes you might have heard also in another way also. That is, if you place 100 order, I will give you the cost, I will give you the product till 100 order, you will get a price of some 100 rupees. If you place an 101 order to 150 order, you will get an additional discount of 1 rupee or 2 rupee per order. Okay, and if you are ordering above 150, you may get an another discount of 2 rupee or 3 rupee. Okay, in these cases what you have to do. So these all things is what we are going to see in the inventory model, and we will be dealing only two models. Okay, as the time is short. Okay, we will be forced to restrict our modeling in the inventory with respect to only two models. One is called the basic EOQ model. That is what you have seen in the previous slide. Okay, the basic EOQ model, and the second will be the EOQ model when price breaks are available. Price breaks in the sense means if you are purchasing so and so quantity, you will get an order discount like that. So these are the two models that what we will be going to see in this inventory modeling. Okay, now as you told about inventory, this number. So we are determining the order number. So what will be the variables in the case of determining this inventory number or the quantity of stock? What will be the variables? Any guesswork? What will be the variables in this case? What will be the variables?
Sir, it is the amount of time required to manufacture given product.
Okay.
That,
so all this. So
that's the factory size.
So manufacturing of a product, I am not bothered actually in the case of inventory.
Oh,
Okay.
or the larger godown size, sir.
larger godown size.
The storage capability.
So yeah, so I'll tell storage capability and all things. What basically where it will or where it will have the implications. If you want to have, if you want to hold a larger storage space, so what will be more? The associated cost will be more. Okay, so basically the costs are the function which will tell you, okay, how much quantity you can stock, okay, and or how much quantity you can keep you can keep for a safety stock, etc. So these all terms you will be calculating based on the terms called inventory cost. Okay, so that is called as inventory cost. So what are the various costs involved in the inventory? So the first one, that is called purchase cost. Okay, so that is called purchase cost. The second one term, that is called as ordering cost. The third one is called as inventory carrying cost. The fourth one is called as shortage cost. Okay, and the total cost of inventory. Okay, so the total cost of inventory, so that will be the summation of purchase cost plus total variable cost for managing the inventory. So purchase cost plus inventory carrying cost plus ordering cost plus storage cost. If you sum all these things together, you will get total inventory cost. Now we will see what are all these things individually. What is actually purchase cost? What is basically the purchase cost is? So purchase cost is nothing but price per unit multiplied by demand per unit time. Demand per unit time. So I can say that CU into S. Okay, where okay, a CU into S. So CU is the price per unit and demand per unit. We are representing it as yes, CU into S. So where CU is a unit cost and S is the annual demand. Okay, so S is my annual demand and CU is the unit cost. Okay, now what is this ordering cost? Now what is this ordering cost? So ordering cost involves receiving quotations, the cost involved with receiving quotation, processing purchase requisitions, receiving materials and then processing it, following up, okay, and expediting purchase order, processing seller's invoice, etc. Okay, so these all things put together, we call it as ordering cost. Okay, the cost of placing an order. The cost involved in placing an order, that is normally called as ordering cost. Okay, so this cost is normally taken as C naught by Q into S. Okay, S is my annual demand. Okay, and C naught is the cost of placing an order. Okay, C naught is cost of placing an order. and Q is the order quantity. Q is the order quantity. So purchasing cost is seen, then ordering cost is we have seen. Now what is this carrying cost? What is this carrying cost? So this includes, so the carrying cost includes rent of storage facility, then salaries of personnel and related storage expenses, then cost of deterioration and spoiling, cost of insurance, cost of capital, that is interest lost or capital invested. Sometimes some special tax also you are supposed to pay. Okay, for storing certain items. So how long you are going to how long you are going to hold the inventory with you? So the carrying cost you have to take into account. Okay, so it involves all the information that is required for you to hold the stock in your inventory. So the annual, if the so in this case the carrying cost. So carrying cost will be Cu into I into Q by S, where Cu is the unit purchase cost already is written. Okay, I is the interest rate. Okay, I is the interest rate and in which you are supposed to hold your quantity in your stock. So if I plot these two, that is the ordering cost and your carrying cost. One will be a function like this and another will be a straight line like this. Yeah. So what is what? What is what? So this will be your carrying cost and this will be your ordering cost. Okay, so this is cost and this is quantity Q. Okay, so again the same here, it is also cost and this is Q here. That is the ordering cost. If you see what you can observe from these two curves. What you can observe from these two curves, these two individual curves. You can see to that when you are ordering more numbers, okay, when you are ordering more numbers in a same order, your ordering cost is reducing. When you place an order, okay, when you place an order, okay, you can see that when the quantity number increases, okay, the ordering cost reduces. Okay, but you can see that the cost associated in stocking that product, okay, as inventory will increase as the numbers are increasing. So Q here is quantity. Okay, and the total cost normally will be the summation of this ordering cost and carrying cost. Okay, the total cost will be the summation of this ordering cost and carrying cost. I'll come to it. There is one more cost which I left out. The last, that is called as the shortage cost. What is it? Shortage cost. See, sometimes because your product is not there in the stock, you are losing a business. For that, you are basically adding a penalty. So that penalty cost, that is called as the shortage cost. Okay, that is basically called as the shortage cost. So now I'll come back to these two, the ordering cost and carrying cost. So I'll take a new page and let me draw these two again. Okay, so as you have seen earlier, so your ordering cost, okay, that initially is high. Oh, sorry. That initially is high, and then okay. So that's how the ordering cost will be drawn. Okay, and the next carrying cost. And you can see there is a point at which, okay, there is a point at which they are intersecting each other. Okay, there is a point at which they are basically intersecting each other. Okay, and if you plot the total cost curve, okay, if you plot the total cost curve, that will be the minimum point. Okay, wherever the costs, wherever both the costs are meeting together, that, and if you plot it, the corresponding value, okay, the corresponding value, okay, the corresponding, so the corresponding will be the minimum in that model. Okay, and that represents, that quantity represents. So here in my x-axis I have annual cost, and this is quantity. Okay, so and this is what I told you, ordering cost. And this is carrying cost. This is total cost. So the total cost will be minimum at the meeting point of the ordering cost and carrying cost curve. And the corresponding order quantity where the total cost is minimum, that is normally called as EOQ. Okay, or the economic order quantity. Okay, the corresponding the minimum in your cost curve will be the same point at which your ordering cost and carrying cost will be meeting, and the corresponding quantity, that is called as economic order quantity. So here in the inventory model, okay, so you will be determining the first one, okay, the first one you will be determining this economic order quantity. Okay, so for the various models you can determine, okay, next one you can determine the optimum numbers of orders planned, okay, optimum numbers of of order planned, you can determine, you can also determine the minimum total inventory cost. Okay. On third one, the time between orders. And fourth one, total cost of inventory. So these are the things what we will determine from the inventory model problems. The order quantity, the optimum numbers of order plan, time between orders, and total inventory cost. Okay. So now, if you want to basically, this has got lot of derivations are also involved. So for getting the final equations, so we will straight away will give you the equations. Using that equations, you can able to solve it. So good afternoon. So we have discussed in the yesterday's class regarding the costs which are involved in the calculation of EOQ, and also we have discussed about what do you mean by the term called as EOQ and how this is coming. So this we have discussed in the yesterday's class. So today we will straight away will move into our first model. Okay, that is we have discussed in the yesterday's class itself, the model number 1, where there is no all are of uniform time interval and you are going to place the order, okay, at your half inventory level. And we will see how to calculate the equations of EOQ and other form other functions what has been given over here. We will discuss. We will solve one or two problems in this regard, and we'll proceed to our model number 2. Model number 2 in the evening class. So we have discussed our first model. Okay, so we have discussed our first model, that is of uniform demand. Okay, the demand, everything, the demand is also uniform. So there is no seasonal demands are not taken into our account. Okay, so this is our case first case that we have discussed. So initially I had a maximum inventory. Okay, so my maximum inventory is this. Okay, so that is my maximum inventory, and I had an average inventory that is exactly half is also available. Okay, and there's a safety stock is also available to me. So that is my maximum inventory as the so here this is quantity. Okay, here that is a quantity and here it is time. Okay, and you can see as the time progresses, the item will be getting in my stock sold off, and that is going to reach to the zero condition. So when it is touching almost here, I will get my order completely back into the stock. So the item will again reach to the full inventory level. So again, you can see as the time progresses in the same fashion, that will get reduced. Okay. And again, when it is going to touch to the ground, okay, again, I will get order back into my stock. Again, my stock will rises to the full inventory condition. Okay. So this is how the cycle will continue with of uniform time in. Okay, this will continue with of. That is, there are models are available that varying time interval that is also possible. Okay, so this distance. Okay, so this is the maximum quantity that will in our. So that is called as the Q. Okay, so this is Q. So Q is the maximum inventory point, and the half of it. So the half of it, that is also I have told you that this will be the average inventory. Okay, this is the average inventory. So that is equals to Q by 2. Okay, and there will be points will be there in our model, something like B. Okay, so here I can mark one point. So that is called point number B. Okay, there will be a point will be here somewhere here. So that is a point called C. I'll give you the explanation. And the bottom will have the point D. And on the top, you will have the point A. Okay. So now what are these points? What are these points indicating? Okay. What are these points indicating? So I have B here. So that's my B. This is my point number C, and this is point D. Okay, so if we say the point A, what is the peculiarity of the point A? What is the peculiarity of point A? That is the inventory, the maximum inventory is shown at point A. Okay, so maximum inventory, that is point A. Okay, what is point B? What is point B? Any guess? So you have to initiate the process of purchase. Okay, the process of initiating the purchase. So that will start at point B. You will start the process of initiating the purchase. Okay, so process of initiating the purchase. So that you will do at point B. Okay, so point B. So normally that is taken as the process initiating the purchase that will be done at the point of average inventory. Okay, so that will be average inventory. Now you can see there is a point C. Okay, point C. What is this point C? What is this point C? What is this point C? Any guess? So point C, you are basically placing the order. Okay, you are basically placing the order. Okay, you are placing the order. So that point is basically the point number C. Okay, so I can say that that is the reorder point. Okay, so that is the reorder point. So that is basically point C. Okay, and at point D, okay, at point D, what happens? Point D, what happens? Point D, the item will be back into your stock. Okay, the item will be back into your stock. So D point, so mostly the D point will be taken into account. The D point will be fixing based on our condition of safety stock. Okay, though I touched that into the zero, you have to always keep in your mind to keep the safety stock. So point D, okay, so point D, wherever the ordered quantity you are receiving, that will be normally based on your safety stock. Okay, so at point D, so item back into stock. Okay, item back into stock, that is point D. So point D, it will rises again back into point A, and the cycle will continue. Okay, and you can see now, you can see over here now there are two terms will be there. So point between BC, and there is a distance between CD is also available. So this distance is called as RT, and this distance that is called as PT. Okay, RT and PT. The distance between B and C, that is called RT. Distance between C and D, that is called PT. And put together the distance between B to D, that is called as L. Okay, that is called as L. So RT corresponds to requisition time. Okay, so RT corresponds to requisition time. Okay, requisition time. That is, you want to place an order. For that, sometimes you need to go for bidding. Okay, sometimes you have to negotiate. Okay, the prices has to be negotiated, etc. So that is basically the point. That is basically your requisition time. PT is normally the procurement time. That is, you have placed the order, that company has to deliver the goods to you. So that is basically the PT, that is called as the procurement time. Okay, so that is called as the procurement time. And together RT plus PT, okay, RT plus PT marked as L, that is called as lead time. Okay, so that is the time required normally when you are placing an order to get your item back into your stock. That time, that is called as lead time. So requisition time is the time that has to happen from your side. Procurement time normally will be the time that is being requested by the vendor to supply the product when once you place the order. So RT plus PT put together, we call it as lead time. Okay, so these are the various points in which you have to understand from this basic diagram. Okay, so lead time you can calculate, RT also you can calculate, PT also you can calculate. Okay. So RTPT is also marked. So lead time is also marked. So these are the information that you can calculate, that you have to know from the diagram. Now, now I'll straight away will move into the equations. I don't want to give you any how we are arriving at all things. I am not going. So we'll move into the equation. So if I want to find this Q, so Q, it is sometimes marked as Q naught or EOQ. Okay, all are remains the same. Okay, so the for our this particular model, so the EOQ. Okay, so you have to determine the EOQ here. So this is EOQ, or sometimes it will be marked as Q naught, okay, etc. That's the way that will be marked. So that will be depend totally on the cost. So 2 into C naught into S divided by Cu into I. Okay. So what is C naught? What is C naught? So C naught is the setup cost per production and Cu is the unit cost of an item. Okay, unit cost of an item. So we have written over here, we have written over here the EOQ, optimum numbers of order plan, time between orders and total inventory cost. So the same thing I'll write here again. So EOQ. Okay, anyhow, it's written here, so I don't want to go back and write here. Yeah. So EOQ we can calculate by using this particular formula. Okay. And the second thing is optimum numbers of orders plan. Okay. So optimum numbers of order plan. So once you know the EOQ and once you know the total demand, you can see how many orders you have to place in a here. Okay, so basically this equation you have to know for solving the problem in this particular part. Okay, and then optimum length between order, when once you know the total demand and order quantity or the number of orders you are placing, you can calculate the frequency. Okay, you can calculate the frequency easily, that when an order has to place. Okay, and then you have to calculate the inventory carrying cost. So it will be square root of 2 into C naught into S into Cu into I. So that alone I will write here. Total cost of inventory, that will be equal to square root of 2 into C naught into C naught into S into Cu into I. Okay, so we have discussed here the ordering cost, carrying cost in terms, etc. in the yesterday's class, where the C naught is coming, where the Cu is coming, where the I is coming. These all things we have discussed in the yesterday's class. So that's why I am taking it directly taking it to the formulas. I am not going to repeat it back again. So these are the things what you will be calculating here. You have to calculate the EOQ. You have to calculate when to place the order. So when to place the order and how much quantity you have to place the order, that we will be addressing basically in the inventory models. So any doubt in so far equations? Any doubt in the so far equations? Any doubts? Okay, so I'll go to a problem directly. So the question is, there's a company is there. So a company requires 16,000 units of raw material. Okay, 16,000 units of raw materials costing rupees 2 per unit. Okay. Cost of placing an order. Cost of placing an order is rupees 45 and carrying cost are 10% per year. Per year per unit of average inventory. Average inventory. Determine first one, the economic order quantity. The economic order quantity. Second thing, cycle time. Third thing, total variable cost for managing the inventory. Yeah, so that's a question. Please tell me how to proceed. What all things are given? What all things are given and how to proceed? So what are the given data? What are the given data? So demand is given, annual demand is given, annual demand is 16,000 units. Okay, and cost of placing an order is given. Okay, cost of placing an order is given. Unit cost is given. And inventory carrying cost is also given. So demand equals 16,000 means it is S equals 16,000. Okay, S equals 16,000. Then you have given the unit cost CU. Okay, CU is given. So CU is rupees 2. Okay. Then cost of placing an order is given. So cost of placing an order is C0. So C0 is given as 45 rupees 45. Okay, rupees 45. And the annual carrying cost, the inventory carrying cost, that is also given 10%. So that is basically the interest rate I. So I is given as 10%. So the value will be 0.1. Okay. So the economic order quantity, the first thing, these are the given data. The first one, you have been asked to calculate the economic order quantity. So 1 EOQ. So EOQ, the equation is square root of 2 into C0 into S divided by CU into I. So all datas are known to us. Square root of 2 into C naught is 45. So 45 into 16,000 divided by CU is 2 into 0.1. So what's the value you are getting? Get me the result. Get me the result. The value will be 2684 unit. It will be 2684 units. So the annual demand is known. So next is cycle time. So cycle time is okay, 1 divided by number of orders. So next is cycle time, that is 1 divided by number of orders per year. Okay, so you know number of orders per year. So number of orders per year you can calculate. So you know the total demand is 16,000. So 16,000 divided by, so every order it requires 2,684 units. So number of orders per year, so 16,000 divided by 2684. So you will get the value as 6. So you have to place 6 orders per year. So that means you have to place 6 orders per year. So therefore cycle times, therefore what will be the cycle time? Therefore what will be the cycle time? You have to place orders of 2,684 units on every 2 months. So per year you have to place 6 orders. So every 2 months you have to place an order, and the order quantity, the economic order quantity will be 2,684, so that your total cost will be minimum. Okay, so that will be 2 months. 2 months. The third one, so TIC. Okay, so TIC, so that is C naught into S by Q naught plus so C naught into S by Q naught, that is one term. Second term plus Cu into I into Q naught whole divided by 2. So that's a term number 2. So you can substitute it. The first term you will get it as 270. Second term you will get it as 268.4, and the total cost will be rupees 538.4. So this is what you will be normally determining from the inventory model. So you have determined for the company which requires a 16,000 units on a year. Okay, the company which requires 16,000 units a year, Okay, having a raw material cost of rupees 2 per unit and cost of placing an order is rupees 45 and inventory carrying cost are 10% per unit of average inventory. The economic order quantity we have determined. So out of 16,000 units, you have to place an order of 2,684 units. Okay, on a time interval of 2 months, so that you have 6 orders. You have to place 6 orders in a year of 2,684 to met my unit demand of met my yearly demand of 16,000 units. And the total cost, variable cost for managing the inventory, so that will be 538.4. So this is what we will be calculating in the case of inventory models. So anything which is not clear, we will discuss right now. Any point, if it requires a little more explanation or any detailed explanation, we can have right now.
Sir, in the calculation of cycle time, sir.
Yeah.
Sir, the number of orders per year we found as 6, no, sir. Then cycle
Yes.
time is 1/6, no, sir.
Eh?
Number of orders per year we found as
Per
6.
year.
Yes, sir. We
Into,
found that as 6.
yeah.
When then cycle time is 1/6, no, sir.
1/6 of a year.
Okay, sir. Okay, sir.
Okay, 1/6 of a year.
Okay,
Per
sir.
year. 1/6 into 12.
Okay, sir. Understood, sir.
Okay, so that will be 12/6. So I have written here total variable cost for managing the inventory. So there are 2 terms are there. So the first term C0 into S by Q0. So that you can take it as annual cost of ordering, and the next wherever the CU into I term that is coming, that is annual inventory carrying cost. So the total cost will be the summation of 2 terms on annual cost of ordering plus annual inventory cost. So that is what we are determining here. Okay, so this is annual cost, that 270, the first term, that is annual cost of ordering. Second is annual inventory carrying cost. Okay, so that you have to note down. Okay, so the first term, so TIC, I think I have. Yeah, so that's not written here. Yeah, so this is the total variable cost for managing the inventory. So this total variable cost for managing the inventory, that is only we have calculated. So that will have 2 terms, annual cost of ordering and annual inventory carrying cost. So that is the summation. You will get it as the total variable cost for managing the inventory. So any other points to be discussed? Is it clear? So I'll give you a problem to work out. So a manufacturing company needs ball bearings. Ball bearings of worth rupees 28,800, worth rupees 28,800. 800 per year. Per year. The cost of placing an order so the cost of placing an order is rupees 48 is 48 and inventory carrying cost has a percentage of average inventory investment is 12%. Determine first one, value of each assignment. Value of each assignment. And second thing, number of orders per year. Number of orders per year. You can stop. So a company needs ball bearing. Okay. So it is not, the quantity is not given. It is cost is given. Quantity is not given. Why? Because there are various ranges of sizes might be available. So in order not to confuse it, so on various sizes, they have told that the total cost for a year is 28,800. And cost of placing an order is 48 and inventory carrying cost as a percentage of average inventory investment is 12%. Okay. So the given information will be, okay, so the given information in this problem, so that will be basically S into CU. Okay. So the given data is S into CU. So S into CU is rupees 28,800. Rupees 28,800. And the other information whatever is given is cost of placing an order. Okay, so ordering cost, so C naught is given. Okay, so C naught is given as rupees 48 and inventory carrying cost, so inventory carrying cost I is given. Okay, so I is also given. So I is something like 12%, 0.12, 0.12. So that this information is given in the problem. So they didn't ask you to calculate the EOQ. They have asked you to calculate the value of each assignment. Okay. So value of each assignment, okay. So value of each assignment, so that will be EOQ into CU. Okay, EOQ into CU. So EOQ into CU, so that will be equals to Q naught into CU. Okay, and Q naught or equals square root of 2 into C naught into S divided by Cu into I. Okay, So we can see that CU, okay. So CU equals, so we can take it out the CU from that, since CU is not known to us. So CU, you can take it out in terms of this equation. So Q naught into CU, yeah, so Q naught into CU will be equals to square root of 2 into C naught into S into Cu divided by I. Okay. So this I am equating on the both sides, then I am taking it out. So that's why I am multiplying here the S into Cu term directly over here. So all the terms are known to you. So 2 is known to you, C naught is known to you, S into Cu is known to you. Okay, and I is also known to you. So if you substitute it over the it will be 2 into C naught as 48 into 28,800 divided by 0.12. So you will get the value as cost of each assignment will be rupees 4,800. Okay, the cost of assignment is 4,800, and the cost of total orders per year is 28,800. So number of orders, per year, that will be equals to 28,800 divided by 4,800. So that will be equals 6. Okay. So S into Cu is given. So that's the way I'm equating it. Q naught into Cu I am determining. Okay, so EOQ is already known to you. You have to calculate it. So using that information, I am calculating it, and I am getting the value for each assignment I am calculating. Once the value for each assignment is known to you, I can able to determine number of orders per year, what is required. So I hope that part is clear. So okay, good evening. I hope I am audible. So we'll straight away go into the problem. So morning we have discussed one problem like this. One more also we have discussed. So two problems we have discussed in the morning. So I'll give you a third problem. So you can just try this. Okay. So it's an industry needs 5,400 units per year. Okay, the ordering cost is 250 per order and carrying cost is 30 per order. As rupees 30, find EOQ and number of orders per year and time between successive orders. So how to proceed? So how to proceed? So the EOQ equation we have already seen. Okay, so what all the data given in the problem that we will see. So S is given, so demand is given. So S is given as S is 5,400. Ordering cost is C naught. So C naught is 250. You have carrying cost CU. Okay, I is not given, so you can take it as CU into I. So that is 30. Okay, so you can calculate EOQ or the Q naught. So Q naught will be 2 into 250 into 5,400 divided by 30. What's the value? What is the value? Can someone substitute it and get me the value?
$90,000, sir.
90,000. It's a square root.
So 300, sir. Taking square root.
Yeah, taking square root, it is. What is it? Sorry. Here I'm sorry. Yeah, okay. So square root, so that is 300 units. Okay, so EOQ is 200. So here also that square root is there. Okay, now yeah, so 300 units. So now the next is number of per year. So number of orders per year. What's the value? 5,400 divided by 300. How much?
18, sir.
So 18 orders. So 18 orders per year. Okay. Now time between successive orders. So time between successive orders. How will you find? So 18 orders in a year you need to place. So time will be less than 30 days. What is the exact value?
Sir, 1/3 of a month.
Yeah. Yes, so approximately 20 days you need to place one order. Okay. So approximately 20 days you need to place an order. So 18 orders, so 12 months a year, so that will be 1 by 18, so it will come as, yeah, to 1 by 18 of a year, so that will be 12 by 18. Okay, so approximately equal to 20 days you need to place an order. Okay, is that idea, is that methodology, everything is clear to you right now? Yeah, one more problem you can just have a try. So this is given in the question that annual demand of an item in the stores of a foundry is 9,000 unit. So demand is given. So demand is S. So S equals 9,000 units. Okay. Annual carrying cost is 15% of the purchase price per item. So I is given. I is 0.15. Okay. Now what else is given? The purchase price is 20 per unit. So CU is rupees 20. Okay. The ordering cost is given. So CU. So C naught is given. So C naught is rupees 15 per order. Presently, the order size of the item is the average monthly demand of the item. Okay. So they are not following the EOQ condition. The company is not following the EOQ condition. The company is following a thumb rule in such a way that the average monthly demand is being taken into the consideration. Find the economic order quantity and compare it cost with the present ordering system. Okay, so yeah, so what is the present situation? So average monthly demand, so 90,000 roughly, so 90,000 by 12, how much quantity? 9,000 by 12, how much? How much? What's the value? So 750 units. So every month they are placing an order of 750 units. Okay. And to find EOQ, you have, okay, the demand is given, all the datas are given. Now, tell me what is EOQ here? Determine the EOQ for the given condition. Square root of 2 into C naught into S divided by CU into I. Square root of 2 into 15 into 9,000 divided by CU is 20. 20 into 0.15. What is it? What's the value is? What's the value is?
Sir, 300.
That is 300. So economic order quantity is 300 units. And number of orders to be placed is? Number of orders to be placed is 9,000 by 300. How much? So that will be 30 orders. Okay. So that will be 30 orders. Here it is 12 orders. Okay. Now what will be the cost? What will be the total cost? Okay. What will be the total cost for all the criterion, for both the criterion? What will be the total cost? So total variable cost we have calculated, and okay, so total cost is also, we have the equation here. So total cost, we have the equation. So total inventory cost is square root of 2 into C naught into S into CU into I. Yeah. Okay, so substitute both the values here in this case. Okay, and get me the result. The total cost for yeah. So wait for some time. The cost part is not like that. Okay, so the cost part is not like that. I'll come to it. Okay, so you don't need to. So you have to, you can calculate the total cost. Okay, so you can calculate the total cost. So annual total cost. So annual total cost. So that will be the summation of three things. So one will be annual material cost. So that is CU into S. CU into S. Second one, it will be annual procurement cost. Annual procurement cost. So annual procurement cost is S by Q into C naught. Okay, S by Q into C naught. And the third term will be annual inventory carrying cost. Annual inventory carrying cost. So that is half into Q into Cu into I. Okay. So I had here two cases is there. Okay. I had here two cases is here. One is order quantity 750, and next is order quantity 300. Okay, now what is the annual material cost? So CU into S. Annual material cost, there is nothing, there is no change at all. Both the value will remain same. So CU is 20 and S is 9,000. So 20 into 9,000. So here also 20 into 9,000. Okay. Now the second one, annual procurement cost. S by Q into C naught. Okay. S remains same as 9,000. Okay. 9,000. So the first column, the Q value is 750. Okay. 750. And C naught value is 15. Second case, it will be 9,000. It will be 9,000 divided by 300 into 15. Yeah. The third is inventory carrying cost. So 1 by 2 into Q is here 750. So 750 into CU is 20. 20 into 0.15. Here it is 1 by 2 into 300. Okay. 300 into 20 into 0.15. Can you get me the value for all these three? Can someone get me the value for all these three costs? So 20 into 9,000, how much? That is 1,80,000. 1,80,000. Here also it is 1,80,000. Next is 9,000. 50, 12 into 15. So that is 180. Okay, next is $9,000 by 330. So 30 into 15. So that is 450. Okay. Now next is 0.5 into 750 into 20 into 0.15. 1,125. 1,125. Second is 0.5 0.5 into 300 into 20 into 0.15. So that is again 450. So the total value is 450 plus 450 plus 1,80,000. So in the order quantity, the value will be 1 lakh. So in this case, the cost will be, the total cost summation will be, so here I am writing. Okay, so the total cost is rupees 1,80,900 if they follow EOQ. So that is a summation of all these three. Okay, summation of all these three, 1,80,900. The other case, it will be
1,81,305.
yeah, so yeah, correct. So that will be rupees 1,81,305 if you submit all these three. Okay, so now which one is recommendable? Now which one will be recommendable?
EOQ is recommendable.
EOQ is recommendable. So that is comes off the minimum cost. Okay, so you can calculate the difference. The difference will be the cost advantage. Okay, the difference will be the cost advantage. The difference among these two will be your cost. Is this clear? So this is the methodology which you will have to follow when price discount is also asked. Okay, when price discount is also asked, this is the methodology which you have to follow. So one column there will be for EOQ, the another column will be there for price break one order quantity. There will be third column will be there if you have more than one price breaks are available. So according to the number of price breaks, the number of columns will also increase. Okay. So there also you have to compare it like this. For the given condition, you have to find the EOQ. Then the other order quantities might be mentioned over there, or from the statements you have to understand it. And you can compare the total cost, the annual total cost comprising of these three factors. Okay. So using that information, you can able to justify whether to go for price discounts or not. If you are going for price discounts itself, which order quantity will be better? Always EOQ model need not to be better. Sometimes price discount cases will sounds better. So that you can only compare based on the annual total cost only. You can able to compare it. Okay, so I'll just quickly go through the other models. Okay, other models that are also available in this inventory model. Then I'll come back to this case. So I hope point is visible. Yeah, the model one we have seen. So this is how, this is what is basically we are calculating. Okay, this is what we are basically calculating, the EOQ and the corresponding minimum total cost were the point at which your cost curve is minimum and the carrying cost and ordering cost and carrying cost are meeting together. Okay, so this is the EOQ or Q0, whatever you are determining, and this is the minimum total cost. So these all things we have discussed. So yeah, Now the next model is EOQ when shortages are allowed. So when allowed, the table here Q will Q1 and Q2. So Q is your order size, Q1 is the maximum inventory, Q2 is the maximum stock out. So maximum stock out here is taken as the average inventory. So below the average inventory it is Q2, above the average inventory it is taken in the case as Q1. So the T1 is the time. So T1 you can see during the time frame of T1 you have Q1 quantity in your stock. So that is taken as the period of positive stock. And once it falls below your average time, you can see that the replenishment is able to obtain after the network reaches a time of T2. So from the point of T1 to T2, that is called as period of shortage, and T1 plus T2, that is your cycle time. So Q is the order size. So the ordering cost per order. CH is the same thing. So ordering cost C0, this is CU, carrying or holding cost unit per year. One more cost, please take into account, that is CS. So shortage cost per unit per year. Okay, so this is the addition in the second model. So as a result, you can see the formula is going to change. Okay, so C naught into, instead of demand, yes, it is marked as D divided by, this is your initial term, so CH. Okay, plus CS plus CH divided by CS. So this is an additional term which is coming into the picture. Okay, for Q star. Okay, Q1, Q2, these all things also you can determine. T you can determine Q1 by D, that is T1, T2 equal Q2 by D. And number of orders per period is D demand by Q star always. Okay, so in the Q star, you can see in the calculation of Q, Q naught or EOQ, you can see the third cost, that is CH. Okay, the CS, the shortage cost is taken into account. So this is C naught, this is CU, this is CS. Okay, so CS is the shortage cost. So CS is coming, CS plus CS divided by CS is taken into account for the calculation of EOQ. So this is the only modification in the formula. You can remember this. If the problem, I'm not going to solve any problem on this model. Okay, so you can refer the PPT and cost element is coming, and that has been accommodated in the formula. Okay, so some solved problems only solved, you have the question and result is available. The intermediate steps won't be there. You can practice it for one or two such questions. Yeah, this is not required. This is just to show you a model. The second one, model number 2, you can look into it. This is the third case I told you. Okay, so this is a third case, manufacturing model without shortage, EOQ with production lot size. Okay, production lot size is taken into the factor. So here you can see there is a term is called production rate of the item. Okay, you can see your supply is not coming here in a constant fashion. Okay, based on your supply condition, you are delivering the product. As a result of a constant steep curve, you can see your demand as well as your supply both goes in a slope curves. Okay, this is also slope, this is also slope. Okay, so here T1 is the period of production as well as consumption of the item. T2 is a period of the consumption only. Okay, so during the period of T1, both you are supplying and the product is also being sold out. That is being taken. Okay, when it reaches to the peak, now this is production has stopped. From this point only, the product is being sold out. So K minus R. So that's the way this will continue. So K is the annual demand in the units. sorry, R is the annual demand. That's the way it is getting replenished. So K minus R, here you are supplying it, okay, the product not in an instant, but gradually. Okay, so here instead of economic order quantity, here a new term will comes into the picture, that is called economic batch quantity, EBQ. Okay, EBQ. So EBQ will be the fraction of R by K will be taken into account. So R and R by K ratio has to be taken into account. So this is how the manufacturing models without shortage will work. Okay, this is the third model. Okay, some problems, if you are interested and if you have time, you can go through it. These things are not mandatory for as the exam point is concerned. And the third is manufacturing model with shortage. So this is we have discussed, but here also you can see over here, though K by R case also the shortages are allowed. Okay, so that is the model number 4. The equations are given to you, models are also solved to you. Okay, so that is given. Now this is before coming to this model number 5. There is a model number 5 is also available. It is also similar to our first case. Okay, it is also similar to our first case. So here we can see this all are of uniform time. Okay, from this to this, if we take, the time is constant. This to this, the time is constant. So that's the way the time is constant. You have an uniform demand. So there is a case in which the seasonal demand will happen. In that case, that is the model number 5, where basically this one will have a smaller time period for your items to get sold off. The other will be a larger slope. Okay, some will be steeper slope. Okay, so depends on the unusual time run or the different time run, you will have a different demand will happen. So to represent that, there is another model is also available. Okay, so we are not going to these models. So model number 1 we have solved. Model number 2 I have left it to you. You can practice the problem. Model number 3, 4, all other, you can just have a look. Whoever has an interest can look into it, especially those who are going for some higher studies in this areas, maybe now or maybe in the future. You can work out all those things later. Now I'll move into the last model. So last model, it is given as EOQ with discount. This is what I told you. And we have already solved a problem in the previous problem we have solved in the similar fashion. But here the explicitly more number of layers or more number of conditions are given to you. Okay, so you can see when the quantity is 0, okay, less than Q1, less than B1, you have a price P1. So from B1 to B2, you have a different price. Likewise, when your batch quantity are changing, your price is going to change. So in that case, which one, whether to go for the EOQ model or to select a discount model, and if we are selecting a discount model, which price break model we have to actually select. So that is what we are seeing in this last model, EOQ with quantity discount. And the decision criteria is you have to calculate the total cost. So the total cost comprising of 3 terms we have calculated earlier. One is annual cost of material. So annual cost of material is nothing but it is CU into S will give you the annual cost of material. Then you will have annual procurement cost. So it is S by Q. So please be ensured that Q you have to select it from the corresponding range. Okay, the corresponding range EOQ. That is here, this will be 0 to 100. Okay, so up to 100, whatever the quantity you are selling, you will get a price like this. Second one, you can see to it, this will be 101. So in that case, the minimum order quantity is 101. So 101 to 200. So here this will be 201. So here the minimum order quantity you have to take it as 201. So that's the way you can calculate it. You can compare the total cost and you can come to a final conclusion. That is what basically you are doing EOQ wet quantity discount. Okay, we'll go back to our sheet once again. We'll solve one problem like this, similarly like this, so you can understand it. Then we will wind up this inventory model. So yesterday we were discussing about the inventory models in the class, and we have seen the various types of inventory models, and at last I was discussing about the model called as price breaks. Okay, so in the price break model there is a small mistake which I have made, so I just want to correct it. So in the price break models, so initially I have tried for taking the first figure and tried to figure it out where actually the product is going to lie, or where actually my economic order quantity is going to lie. And then I told that since it is not an inch, I have proceeded. Okay, so that is not the way. Okay, so that is not the way. So it should be the reverse. So if there are 3 price breaks are given, you have to initially check for the last price break. Okay, last I have to check, find EOQ. Okay, find EOQ for the nth last price breaks. And if your order quantity is lying in that region, okay, if your order quantity is lying in that region, okay, then you can say that the order above that quantity is advisable. Okay, you can terminate your iteration there. Not in the first, you have to check first in the last. Okay, if it is not satisfied, go for n minus 1, that is last minus 1. Okay, so last minus 1, you can check for the EOQ and check whether the order quantity lies in that range or not. Okay, so if it is lying in that range, okay, if it is lying in that range, compare the total cost for 2 things. Okay, compare the total cost for 2 things. One is the economic order quantity EOQ that you have got it from this step. Okay, gotten this step, the number you have got, and this number will, then this range will have some border functions as we have seen on yesterday, say 2000 to 3000. So 2000. So compare for EOQ and that border, okay, and that border value. So using that information, calculate the total cost and compare which is suitable and proceed. Okay, if not, okay, if this is also not succeeding, then likewise you can reduce one by one, like that you can go and till the whole condition wherever it is lying, and accordingly you need to proceed. So we have tried to attempt it by solving it with the first. So you have to initially try to solve it by using the last, and you have to see to it what is the condition, and according to that conditions you can compare the total cost. So if it is satisfying here with the last condition itself, no need to compare the total cost. Using that information itself you can stop. Okay, if it is not like that, okay, you can take the criterions accordingly and you can able to solve it in the forward direction, that is from the minimum to the maximum. So in this criterion, you can proceed. Okay, so this is how you have to proceed, not the vice versa situation that we have discussed in the yesterday's class. So we'll see some problems with the price. So I think that you can able to see the question which is there on the screen. So the question is, find the optimum order quantity for a product for which the price breaks are as follows: 0 less than or equal to Q1 less than 650, 650 less than or equal to Q2 less than 800, 800 less than or equal to Q3. So three price breaks are given. So if you are buying the product up to 650 quantity, you need to pay an amount of rupees 20. The unit price CU is 20. If you are ordering between 650 and 800, that is 651 to 650 to 800, you can see to that the price is 18.5. And if you are ordering above 800, you will be getting a price of 17 rupees 50 paise. That is 2 rupee 50 paise. You are getting it as a discount. So which quantity you are supposed to order? So that is the question. Okay. So you know the what all the things are given. So demand is given. So S is given. Sorry. So S is 300 units. Okay. So I is given. I is 2%. So 0.02. Okay. And ordering cost, so CO is given. So CO is rupees 400. Okay, and CU is given. So CU, okay, so CU it is given CU3. CU3 is 17.5. It is CU2 is 18.5 and CU1 is 20. Okay, so first you have to calculate for the last, that is based on CO3, based on CU3. Okay, so based on CU3, so EOQ, okay, so EOQ will be square root of 2 into C0 into S divided by CU3 into I. What is the substitution you are getting? So 2 into 400 into 300 divided by CU3 is 17.5 into 0.02. Yeah. So what is the value you are getting?
828.
828 units. So what is the situation? So what is the situation? So what is the situation here? Yeah, you can see that it is a 800 greater than or equal to Q3. So that is a condition which is told over there. So definitely you can go for ordering 828 units. Okay, 828 units you can order. That is taking the discount as advisable in the case. Okay, so taking this result, so taking in this way, that is advisable. Right?
Yes, sir.
Okay. So Q0 is equal to QO3 range. So there itself you can terminate. So you can order 828 units. Okay. So now I'll give another one problem. Yeah. So this is another problem. Okay. Annual demand for an item is given. Okay. So S is given. So S is 6,000 units. C naught is 600. I is 0.18. Okay, and price break. So CU3 is given. So CU3 is 9, CU2 is 15, and CU1 is 20. So tell me the Q star values for the three cases. Again, Q star or EOQ, you can calculate using the formula square root of 2 into C naught into S divided by CU into I.
So
For
when we take CU3, we'll get 1414, 1414. So should go to unit 2.
1114.
14.
Yeah, okay. So that you cannot select since it is above 4,000. So that criteria is not satisfied. Yeah. Next one.
Sir, I'm wrong, sir. 1 minute.
Pardon me?
Sir, it's no, sir. It is 2108. I took 20. It is 9.
Ah,
2108. Still, it is wrong.
okay. 1 minute. I have also entered it wrong. So for 9 it is 2000.
108.
108. Okay. So not in the range, not greater than 4,000. Okay. With 15.
1632.
1632. Is it in the range?
No.
2000 to 4,000. No, that is also not in the range. Ignore it.
For
Then
20, yes, it is possible. It is true.
how much?
1414. 1414.
1114.
414, not 414.
1000.
414.
414. 1414. Okay. So the 2 is not in the range. The lowest is only in the range. So in that case, you have to compare. So this is not advisable. This is not advisable. Now you can compare the cost, the total cost, and see to it where actually that is going to fit. Okay. Yeah. So you have to compare here. So you have to compare here three things. So one is for the quantity of 1114. Okay, 1114. Then it is for the order quantity of 2000, and next is order quantity of 4000. Okay, so you have to take the value. Okay, so Q star equals, okay, the Q value is here 1414, and CU is 20. Here the Q star is 2000, that is the starting range of the next one, and CU is 15. Next again is Q star is 4000 and CU is 9. Okay, can you get me the result? Can you get me the result? So SS constant, SS 6000. So 6000 into 20, 6000 into 15, 6000 into 9. So C naught is 600. So this is 600. 600 into S is 6000. 6000 by Q. By Q is 1414. Again 600, 6000 divided by 2000. Here also it is 600 into 6000 divided by 4000. Here it is CU. CU is 20. So 20 into 0.18 into Q star 1414 by 2. Here 18 into 0.18 into 2000 by 2. Here it is 9 into 0.18 into 4000 by 2. Solve it and get me the total cost value.
Sir, first one is 1,25,091.1.
It is 1,25,091.
25,091.
25,000 and 091.
091.
Okay, right.
Sir, second one 96,300.
96,300. Okay.
Thoran, sir, 58,140.
58,000.
140.
140. Okay. Now, where basically the cost is getting reduced. Okay. Now, which model does the cost is minimum?
Greater than 4,000.
Greater than 4,000. So, what's the situation? You have to accept or you have to reject.
Accept.
You can accept.
Accept.
You can accept. Okay. So the third criterion, since the annual total cost is minimum, you can accept the third criterion. Okay. So this is how you have to approach or you have to solve the problem. Okay.
Sir, in the earlier problem, sir, in the earlier problem, no. Like, should we calculate this annual cost?
Should we calculate the
Annual cost in the last problem.
It's
Yeah,
not
so
required. Not required. Your objective is to suggest which one you have to process.
Okay.
Okay, your job is to say whether the price break is advisable. If so, which band of price break is advisable. Okay, so the directly itself you are getting that going above 800 is advisable.
Okay, sir.
So no need to compare those things. Right. Okay. So now this is solved. Yeah, now this is the next problem. This we have attempted on yesterday. Okay, we'll quickly see its result from the PPT. This is the case 1098 4800 524. Yeah, 424 4824. Yeah. So this is the case. So again, the same way you have calculated for the lowest. Okay, 1581. The criteria is given. So 0 to 1200, 1200 to 2000, and greater than 2000. So B1, B2, B3 is given. Price is 10, 9, and 8. So as I told you, we have to initially go for 8, then we will go for 9, then we will go for 10. So the demand is given, C naught is given, I is also given. CU3 is given, CU2 is given, CU1 is given. So the lowest range I have calculated 1581 I got. Does it falls? Okay. Does it falls under the criterion? 1581? No, it is greater than 2000. So it is not falls under the criterion. Okay. So I have gone for the next step. So for 9 rupees, I have calculated. So 9 step I am getting is 1491. Okay. So so what is the status? Is it falls under the line 1200 to 2000? Is it falls under the line?
Yes.
Yes, so it is falling under the line. So when it is falling under the line, which two I have to compare? Which two I have to compare?
Greater than
Second.
2000 and second and third.
We have to compare. Yeah, we have to compare the second and third. Okay. So 1491 is compared and 2000 is also compared. Okay. So 1491 is my EOQ what I am getting here. So that EOQ is compared with the next highest stage. Okay. So when I compared the total cost, so here put together I have written the cost. That's all. There I put a table and calculated it for you to understand each component what it is. Okay. So if a specific component has been asked to you how to differentiate and how to calculate it, we have used that previous table. So everything is put here and it is compared. So the total cost is lower in the case of order size of 2000. So that is accepted. Okay. So here lower price didn't satisfy. Next higher satisfied. So compare that order quantity with the higher quantity, with the higher order quantity. Okay. So that too is compared and I have obtained the result. And for a safer side, if you want to calculate here, you can calculate here the 1200 condition also if you like, and you can compare. Okay. So this is how we are calculating it. This is already we have solved. So is that clear? So if you solve here, you will get the third price band will be recommendable. Correct?
Yes, sir.
I hope the ideas are clear. Okay. Now this is the last question. Quickly go through it and try to get me the result. Yeah, tell me what are the conditions here. So SS 2000. Okay. Ordering cost is given C naught as 10. Okay. I is given as, yeah, in carrying cost is RE point also. I is 0.16. Okay. And purchase price is ₹1 per unit. Yeah, so CU, sorry. So CU 1 as ₹1. Okay. What is the other condition given? Find the economic order quantity and total inventory cost. If a discount of 5% is available for orders of 1000 unit. Yeah, so what is that information? If a discount of 5% is available for orders of 1000 unit, and also if he purchases a single lot of 2000 units, he has to pay only ₹0.93 per unit. Yeah, so CU1 as 1. So next band is 1000. Okay, 1000 less than or equal to Q2, less than or equal to Q2, less than or equal to 2000. Okay, CU2 is 0.95, 0.95, and if it is 2000 greater than Q3, you need to pay only 0.93. So 0.93 is CU3. Okay. So now for the three cases, get me the EOQ. For third, that is 0.93. EOQ is, what is the EOQ value? So I am getting it as 519. Okay, so 519 will not satisfy. So second 0.95. So in that case also I am getting 513 units. Okay, so not satisfied. So now first case. So that is for ₹1. EOQ is 500. So 500 units, that is satisfied. Okay, so if that is the case, again you need to put the table, or you can calculate the annual total cost for the three criterion. So what are the three criterion? So what are the three criterion? One is for 500. One is for 500 and 1 rupee. Next is for, what will be the next one? So one is Q equals 500 and CU1 is 1. Next is Q equals 1000 and CU2 is 0.95. Third is Q equals 2000 and CU3 is 0.93. So CU into S. So 1 into 2000, 0.95 into 2000, 0.93 into 2000. So C naught is 10. So 10 into 2000 by 500, 10 into 2000 by 1000, 10 into 2000 by 2000. Here CU is 1 into 0.16 into 500 by 2. Here it is 0.95 into 0.16 into 1000 by 2. Here it is 0.93 into 0.16 into 2000 by 2. So get me the answers quickly. I think the first value is 2080. You can check the value. Second is 1996. Third value is 2018.8. So which is advisable? So which is advisable? The advisable is the lowest cost. That is the second criteria. Go for order quantity of 1000 at a unit cost of 0.95. I hope it is clear right now. Okay. Always need not to be the lowest, should be the minimum. Okay, sometimes mid, sometimes the highest. So however it comes, you have to select it. So how to proceed, how to select, I hope it is clear to you right now.